All right, so we're going to talk about quadratic functions, and this is kind of a long section, so I'm going to get to it right away and kind of hustle through it so it's not too long for you sitting there watching. But quadratic functions are anything with our x squared, right? So here's the standard form of quadratic. They end up looking like parabolas, right? The rainbows or the smileys, that's kind of what these are going to look like. So we're going to talk about solving quadratics, and we're going to learn multiple ways. One of them you've done already by factoring, setting it equal to 0. That's one way to solve them. And so now we're going to talk a little bit about using completing the square. And completing the square is also used a little bit, a type of completing the square when we are finding centers of circles and so forth. So you will have a choice, but you will have to show me how to complete the square on a test, on an exam. But normally when you're given a quadratic, you can choose however you want to solve it. All right, but you will have to be able to do this for me on our exam for this. So I'm just going to kind of take you through. So here's the standard form, right? And a cannot equal 0, obviously, because there wouldn't be an x squared if that were 0. There would be no number there. And so here is the standard form. Okay, and this is we're gonna put it into this kind of a factored vertex form right here, and that's going to help us find the vertex and so forth that we'll talk about a little bit later. So what we're going to do right now, though, is we're going to go ahead and we're going to take this and we're going to solve it using completing the square. All right, and so there's some steps in doing this. I'm going to kind of just talk through the steps as we go through this. So the first thing that you want to do when we solve is you always need this coefficient in front of a. This a right here in front of x squared, the coefficient in front of x squared. You need this a to be 1. It can't be negative and it can't be anything but 1. So we're going to take this equation, we're going to set it equal to 0. That's how we begin. Now we need this, always set it equal to 0. Okay, now we need this to be 1. So whatever this is, we're going to divide by it. But what we do here, we have to do to every single term. All right, we have to divide every single thing by 2. All right, so that's going to be our first step, is just dividing by a. Unless if this is a 1 and there's not a number showing, I don't have to do this step. So divide by a. So I'm just going to put up here so you recognize a, b, and c. All right, so let's simplify that. So now we're left at x squared plus 2x minus 8 is equal to 0. All right, so recognize that this is c over a, right? Because I divided c by a. So that's what we recognize that as. So what we're going to do is we're going to add or subtract, depending on what this sign is right here, a over c to both sides. And really in short terms, we're going to get, this might be a fraction sometimes, but we're just going to get whatever this constant it is, we're gonna eliminate that. So in order to make that 0, we have to add 8, but remember to keep our equation, this equal sign means we keep both sides balanced. If I add a value to one side, I have to add a value to the other side. I can't just add something or subtract something from one side and not the other. That's what an equal sign means. We have to keep it balanced. So here, we're left with this. Okay, so what we're going to do next is we're going to take half this middle, this is a middle term. I say middle term because it's the middle right here. We're going to take half this middle term and we're going to square it. So I'm going to write that over here, half the middle term and square it. All right, so we're going to take half of the middle term. So this is going to be half of 2. This is 1/2 times 2. What's half of 2? It's 1. And then we're going to take 1 and we're going to square it, and that's 1 times 1, so that's going to equal 1. So what I'm going to do, I'm going to take half the middle term squared, which is this, and I'm going to add it to both sides. Remember, I have to add it to both sides. And this is always going to be positive because we're squaring it. So you add it then to both sides. So here we have x squared equals, so I added a +1 to both sides. Half the middle term squared added to both sides. All right, now I'm going to factor this. All right, so our next step then is to factor. So if I want to factor x squared plus 2x plus 1, Okay, this is something that you've already been taught, so I'm not going to review that too much. I want to know what multiplies, what are the factors of 1 that multiply together to equal 1 that I can add to get 2. So if I use 1 and 1, if I multiply them, that gives me 1. If I add them both, plus 1, that gives you 2. All right, so that's what I'm going to do here. Now I'm going to show you, because you've learned this already. It's not a new concept for you. We did that quite a bit in 980. I'm going to show you the shortcut here. So the shortcut here is to just take the variable, the sign, and whatever half this term was, which is 1. And do you see I come up with the same thing? That's just a shortcut to cut time, because you should know how to do this. This isn't new to you. So that's why I can just use this shortcut. If you choose, if you don't remember this, then just go ahead and factor it. That's fine. Okay, it's always going to be a perfect square. It's always going to factor like this. So equals 9. All right, then our next step, now we're going to solve for x. So we want to go ahead and begin that by, we want to square root both sides. Right, because how we undo a square is we square root. So I'm going to square root this, and I'm going to square root this. Now remember, I have to put a plus or minus on that, because it could be -3 times -3, or it could be +3 times +3. We don't know. That's why we put a plus or minus on that. So this square root cancels out the square, right? This is like 1/2 times 2. So this becomes an x plus 1 equals plus or minus square root of 9 is 3. Now solve this for x. So we'll subtract 1 from both sides. So if I subtract 1 from both sides, so I should have 2 answers, right? Because I have a quadratic, I have an x squared up here. And so I should have 2 answers. They may not always be real solutions, but I should have 2. So I have x equals a -1 plus 3, and x equals a -1 minus 3. So -1 plus 3, so x equals 2, and x equals a -4. 2 and -4. All right, now I want you to take a look at this. I'm going to put this into my calculator, Desmos here. And so the original equation here was 2x squared. Okay, I'm going to just hit this house button, and that takes it back to a standard graph, all right? So let's take a look at this. So we have 2x squared plus 4x minus 16. Let's take a look at that graph. All right, so we want to be sure. So in this picture, I have to kind of bring it in a little bit, because a good picture will show, you know, these points, which are your high-low points we're going to talk about here in just a second, your x-intercepts, and where it goes through the y-axis. So it should show all of that. So given this, let's figure out what these are right here. So I'm going to make it a little bit bigger. This point right here, if I can get it at 0, is -4, 0, right? We found -4 to be one solution, and 2 to be our other solution. So the solutions that we find are what we find when we find those x equals is where it goes through the x-axis. All right, those are called your zeros, where it goes through the x-axis. All right. So you can always check it by looking at the graph and seeing that what we came up with is the same thing as what we had found here. So you can always check it with the graph, but you're going to have to show this work. Okay, so let's do one more example here. So I'm going to do another example. Let's see, how about this one? Let's do, might not have left myself enough room. Okay, so let's take a look at this one. So first step, I'm not going to write them all down again, but the first step is we need to get this to be a 1, right? So we're going to divide this by a -1 because it's got to be positive. So we're left with an x squared plus 6x plus 8, and we're going to set it equal to 0. All right, so it's always our first step, get this a to be 1, and then set it equal to 0. All right, so first thing we're going to do is, since we've already done the a over c, this is a 1 now, which is really nice. I don't have to do anything here. We're going to get rid of this. So we're going to subtract 8 from both sides. Okay. All right, now we're going to take half the middle term. Again, this is the middle term. Half the middle term and square it. So we're going to take 1/2 of 6, which is 3, and we're going to square it, which is 9. So over here, I'm going to add 9. And on this side, I'm going to add 9. Okay, now we're going to factor. So let's factor. We're going to bring down the variable, bring down the sign, and half the middle term. And again, if you don't understand that, just go over to the side and factor that out. And then -8 plus 9 is 1. Okay, now let's solve. So now we're going to solve for x. So in order to solve it, we've got to square root both sides. So we're going to square root this, and we're going to square root this with a plus or minus. So these cancel each other out. We have an x plus 3, and we have a plus or minus square root of 1. Well, the square root of 1 is 1, right? 1 times 1. So we're going to subtract 3 from both sides. And we're going to get that answer of x is equal to a -3 plus 1, and x is equal to a -3 minus 1. So x equals a -2, and x equals a -4. So you can go ahead and put this original equation up here, (x squared minus 6x minus 8, into your calculator and see if it crosses the x-axis at those 2 points. Okay. All right. So let's move on to get another sheet of paper here. All right, so now we're going to talk about graphing quadratics. Like I said, we have quite a bit to talk about here. So we're going to talk about graphing quadratics. So we're going to start out with something that's already in this factored form, in the vertex form here. I call it both vertex form and factored form. All right, so this is already kind of in this form. Let me see, where do I put my notes at here? It's already put into this form right here. So standard form can be put, and I'm going to show you later how to put it into this form. All right, so standard form, vertex form, or factored form. All right, so I will write this up here because we're going to probably need that as a reference. All right, so what we want to do to graph this, there's a couple things that I want you to be able to find when you're doing this. And when you're graphing, first of all, we want to be able to find what our vertex is. Now our vertex is going to be like the high point or the low point of a parabola. That's where our vertex is. So if I just have this parabola, wherever it is, okay, that's going to be, the vertex would be right here. All right, or if it's like this, the vertex is going to be that high point. And those that we're going to talk about are going to be our max and mins that we'll talk about here in just a second. So, given this problem that we have up here, so what I want to know is, what is the vertex? So these are things you're going to have to be able to answer. So what is the vertex? Well, vertex is HK. So when I look over here at what HK is, I want to know what this number right here is. Okay, and I want to know what this is. Now remember, when we talked about before, we got this original form was negative. So we have to take what is actually H going to be there. It's going to actually be a -3. So don't forget that. Same thing as when we do the transformations. All right, so what that is here is it's going to be a -3 and exactly what this is right here. That's your HK. Don't forget to always have to change that sign because we're looking at what H is, and H is a -3. Minus a -3 gives us a +3. So change the sign. So we know the vertex. Okay, so tell me, do you think this parabola is going to open up or down? Well, if this is negative, that means we have a reflection over the x-axis. This right here means it's going to open down. So it's going to look like this. If it's a positive number right here, then it opens up. So since it's negative, it opens down. So we're going to say opens down. Okay. What is the y-intercept? So let's look at, these are the different things we're finding here. So the y-intercept, okay, how we find that is we put a 0 in for the x value, because do you remember me telling you this can be a y equals P of x equals y. So we can set that up as a y equals, and in place of the x, we're going to put a 0. And that's how we find the y-intercept. Put a 0 in for x, but we replace this function with just y equals. Okay, so y equals a negative. This becomes 3 squared, 9. So what's a negative 9 plus 1? Y equals a negative 8. So you have to write the y-intercept as an ordered pair, because the y-intercept is where it goes through the y-axis. So the y-intercept then is going to be 0, negative 8. All right, so next thing we're gonna find is the axis of symmetry. Okay, so the axis of symmetry is always a vertical line that goes right through the center of your parabola. No matter how it opens, it goes straight down through. So the axis of symmetry is a line. So because it's a vertical line, it's always going to be an x equals in what we're working with these functions. Okay, so an x equals, and it's going to go through this ordered pair, which is your vertex. So if this goes through the vertex, this is going to be, or even you can look here, but really it goes through the x value of your vertex. Okay, so it goes through the x value of your vertex. Does that make sense? Because this is your vertex, or this is your vertex, whatever it is. If the line goes through it, the axis of symmetry is going to be an x equal. So this would be x equals our vertex negative 3. It's going to go through this x-axis at negative 3. Okay, and don't forget, don't write negative 3. You got to write it as an x equals because it's a line. Axis of symmetry is a line. And then let's go ahead and take a look at the graph. So let's graph it over here with the information that we have. All right, so something like this. Okay, so our vertex is negative 3, 1. So that's where we're going to plot the point. 1, 2, 3. I need a little bit longer here. Okay, negative 3, negative 1, 2, 3, positive 1. So that's our vertex. We know it's going to open down. So we know it's going to go down like this. Well, where does it go through the y-axis? At 0, negative 8. So we can figure that out. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it's going to go through here. So remember that parabolas are symmetrical. So here's my axis of symmetry. It goes right down through the center of that. So it's symmetrical. So if I went over 3 units here, if I go over 3 units here, 1, 2, 3, 1, 2, 3, I can put a symmetrical point there. So I know that's probably enough there to go ahead. It's not the best graph, but go ahead and do that graph. Okay, it's not the prettiest thing I've ever seen. I'm sorry, I'm off there. So 0, negative 8 is what I was showing. And then we did symmetry. So we went over 1, 2, 3. And we had to go over here at 1, 2, 3. So I know I can put a symmetrical point there because this is symmetrical, even though it doesn't look like it, across the axis of symmetry. So once I have those 3 points, that's all I need to graph it. Okay, and I'm sorry, it's a little sloppy, but all right. So once I've graphed it, then can you tell me what is the domain? So the domain is our x values, remember? Well, this goes on infinitely, negatively, and this goes on infinitely, which my x values go positive, right? So that is just a continuous from negative infinity to positive infinity for my x values. That's a domain. Okay, so the range, let's look at the range. That's the y values. You always start from the bottom and work your way up. So this goes on infinitely forever down here. So we're going to start at a negative infinity, and it goes up, up, up till we reach the top of the graph. And we're talking about the range. That's our y value. So what is this y value right here? It's 1. So it goes to 1. It's a continuous line. So that means we have a bracket. It includes 1. All right. So increasing. These are things we kind of talked about before. So increasing. So the graph, you can see here, the y values are getting larger. So that means it's increasing there. So it's going to increase from negative infinity, right? From negative infinity. And then where does it, and remember this is, we always look at the x values at negative 3. Negative 3. And we put a parenthesis because when we start our decreasing, okay, so here is where that graph decreases, right? Our y values get smaller, so it's decreasing, right? So remember, increase, decrease, higher, smaller. higher. That's why we use our y values for that. But we still look at the domain to determine this. So it starts decreasing here, right, which is at a -3, and it goes on decreasing, but my x values get larger, so to positive infinity. And so these, you can't increase and decrease at the same point, which is why you can't put a bracket and equal it to that. All right, now do we have a max or min? Well, if it opens down, we're going to have a high point, which means we have a maximum. If it opens up, if this is positive and it opens up, I'm going to have a minimum. All right, and so it's always going to be, so in this case, since it opens down, I have a high point, so I'm going to have a maximum. And when we talk about high and low points, that's our range, that's our y values, high and low. So what's our highest point of the graph? Well, it's a +1 on the y. So we have a max at 1. You don't have to write the ordered pair. You can just tell me what is the highest point. It's at the 1 on the y value. So we have a max at 1. Okay. All right, so let's keep moving here, you guys. So we're going to do, this one is using the vertex formula. So I'm going to give you an equation like this in standard form, quadratic, I should say, quadratic equation, like this. And I'm going to ask you to find all of these things. Well, this, when it's in standard form, it's not so easy to see where our vertex is, because this is our vertex. So what we have to do is we have to take this standard form and we have to convert it to this vertex form, okay? So I'm going to show you how to do that, but in order to do it, you have to know the vertex. So let's find the vertex first. And there's something called the vertex formula. And the vertex formula is taking b over 2a, negative b over 2a, and then we substitute that back into the equation, whatever answer we get, put it back into this equation, and that will give us the y value. For crying out loud, I'm sorry. Negative b over 2a gives us our x value, and then we take whatever answer we get and we put it back into here, and that gives us our y value. So that's what this formula means. So let's do our negative. Remember, this is a, this is b, and this is c. So negative b over 2a. So our vertex is going to be negative b, so a negative 4 over 2 times a, which is 2. So that's a +4 over 4, which equals 1. So our vertex, our x value is 1. Okay, now we're going to take what we found and we're just going to put it right back into this equation. That's what this means. Substitute it in as the x right here. So we're going to put a 1 back in here. So p of 1 is 2 times 1 squared. Just putting a 1 in for all the x's into that. All right, so this becomes 2 minus 4 plus 5. So that becomes 3. So this equals 3. So that is the y value of your vertex. So you can just find the vertex formula but you have to remember that it's negative b over 2a. And then you take whatever you found, put it back into your equation, and that gives you the y value. So I know the vertex is 1, 3. All right, so now what I want to do is I want to put it into this vertex formula. Into this vertex formula form right there, the vertex form. So p of x is equal to, now the a, now this is, so I used to teach this using completing the square, and it was tough for students to understand, and it was kind of a long process, time consuming. It still is kind of hard for me not to teach it that way, but I think to save time, and I talk, a lot of my colleagues don't teach it with completing the square. So just to save time, I'm just going to kind of show you how you can put this into the vertex form, all right? So we know that this is going to be our vertex that we found right here, okay? So this is A. Well, you know what? This is A right here. We know what A is. So I can come down here, I can put a 2 in for A because I know what that is. And then we have X. And then what is H? Well, it's a +1. So remember, H is 1, so it's going to be -1. It's always going to end up looking like the opposite sign. And then we have 3 is our K, so +3. That's how simple it is if you know the vertex. And that's it. So now that is in vertex form. Okay, so we know the vertex already. but we're going to do some of these things that we did up here. So now after we know the vertex, okay, how is this going to open? Can I just look at this and see how it's going to open? If this is positive, so I'm just going to rewrite, well, I know that. Okay, so it's going to open up or down. Well, if it's positive, it's going to open up, which means we're going to have what? A minimum, because it opens up. So we're going to have a low point if it opens up. Okay, so what is the y-intercept? Well, I'm going to show you another thing that's kind of nice. If I know the standard form, if I go back to the standard form and I put a 0 in right here and a 0 in right here, would you agree it would just come out to be 5? Now I can put it in right here into this form too, and I'm going to get the same answer. But if I have the standard form, it's just a little bit easier to go, oh, okay, this is 0, this is 0. So it's always going to be whatever this constant is. But I don't want you to get confused with saying, oh, it's just the constant, because it's not. If it's in this factored form, I'd have to go in and I'd have to put in a 0 right here, which would be a -1 squared times 2 plus 3, which would give me 5. So if you have the standard form, it's a lot easier. But if you don't, just put it in for x right here. But if I have the standard form, I know it's going to be that. So write it as an ordered pair, 0, 5. And then we have the axis of symmetry. Okay, and remember the axis of symmetry is always in x equals when we're working with functions. And it's always going to be whatever your vertex, whatever this is for the vertex, the x value in the vertex, because it goes through the vertex. So it's x equals 1. So I don't even have to do anything. Once I know the vertex, I can kind of do all this without. And then let's take a look at the graph. So let's graph it. All right, so we have a vertex of 1, 3, so over 1, up 3. That's our vertex. And then we know we have a y-intercept of 0, 5. Right here. And we know it opens up, so it's going to open up. So my axis of symmetry goes through here, x equals, what is it, 1. And so I can do this symmetrical point. I have one here, so I go over 1. I can go over 1 and do that point. And that's pretty much all I really need to do. And one thing I would say is try not to make this too close to a V, because that's an absolute value if it's a V. So you need it to be rounded the best you can there, okay? So looking here at this, there's our graph. Now let's talk about what is the domain. Well, the domain is from -infinity to +infinity. These x values go on both ways. Okay, what is the range? So start from the bottom and work your way up. So what's the bottom? 1, 2, 3. It's 3 and it's a bracket. And it goes all the way up to +infinity. It's a bracket because this is continuous. Is it increasing? Let's see where it increases. Well, here my y values are getting smaller, so it's decreasing. So it increases from this point on the x, which is 1. So it increases from 1 to +infinity. Remember, we use parentheses when we're talking about increasing, decreasing. And then where is it decreasing? It decreases here, over here from -infinity and all the way to 1. So from -infinity to 1. And does it have a max or min? It has a minimum. And what is the minimum point? It's a y value, right? Because we're talking about height. Minimum, 1, 2, 3. It has a minimum at 3, whatever your y value is. And that y value is going to be whatever this is right here. So if you don't have a graph, you can just get it off your vertex. That's your max or min, depending if it opens up or down. Okay, so I know it's a lot, but we're going to keep moving. Got a lot, got more to do. So now we're going to talk about curve fitting. All right. So curve fitting. So bear with me here. I know it's getting kind of long, but bear with me. All right. So curve fitting is when I have a parabola. Okay, and I want to be able to, I'm going to be given the vertex. So the vertex is 2, -3, and it passes through point, is that for real? 869. Okay, I'm just picking a problem here. So 869. So what I want to do is I want to find, okay, well, I know what the vertex is. I know a point that it goes through. Can I put it into this quadratic so I know what the quadratic equation is of it? I just want to know what the equation is. So that's what we're going to try and find. That's curve fitting. We're fitting the curve by taking this information and creating an equation by it. So I would probably start this by putting it into, I think we want to have this first of all put into the factored form. So you just got to kind of get these down, okay? Got to memorize those two forms. So we know a couple things. We know our vertex right here is 2, -3. So that goes here and that goes here. So we can begin with that. So we have A, so x minus 2 minus 3 squared. Okay. Now, what we want to do is we're going to have to solve for A. That's what we're going to have to find. Our first step is to solve for A. So we're going to change this to a y equals, so that we have an x and a y, because I have a point that it goes through, which is an x and a y. So because I know that, I can fill this in. So a y is 69. A is what we're going to try and find. You know, x is 8 minus 3. So now we solve for A. So really all I'm doing is filling in the information I already have. Now I'm going to solve for A. So here we have 69 equals, so this is 6 times 2 squared, so 36. Okay, so let's add 3 to both sides. 72 is equal to, I'm going to rewrite that as 36A. Okay. And then get A by itself, divide by that coefficient. So 2 is equal to A. So just come back to this equation right here. And we now know that P of X is equal to 2 times, actually we're going to look at this one right here. We're going to just fill in, okay, I'm kind of messing up here. Okay, I'm just going to fill in the X minus, I'm going to go here, okay, the X minus 2 squared minus 3. And we're going to get it into standard form, we just have to multiply all this through. So recognize that this is saying x minus 2 times x minus 2. Okay. So I would multiply this together first. So x times x is x squared minus 2x plus 4 minus 3. All right, so we'll distribute through. So we have a 2x squared minus 4x plus 8 minus 3, and then combine any like terms that we have there. So we have a 2x squared minus 4x is a negative 8x, plus 8 minus 3 is a plus 5. So all I do is just multiply. You just got to remember you multiply this first. And this is not x squared minus 4. You have to, this is saying take x minus 2 times itself. So be aware of that, because a lot of students go x squared minus 4 and then the whole problem's wrong. So don't do that. All right, and this is your answer. We have fit that curve given this information here. Okay, all right, one last thing. So this last thing that we're doing is something that you can do on your calculator, okay? And so I'm going to share my screen with another, let me find it here, activity that I have. And so this is just finding, maybe I don't have it set out there. Let me find it. There it is. Okay. Let me get back here. All right, sorry, gotta bear with me here. I need that. I'm gonna stop sharing for just a second here. And I have to bring all these different things up here here we go. Okay, now where's my picture? All right, now we're gonna share. Here we go. So we got a couple things we're gonna do. So, okay, so let's take a look at this problem right here. So we're given a ball is projected directly upward from an initial height of 100 feet with an initial velocity of 80 feet per second. So this is something that you would be given, okay, a little bit of physics, okay, but they're just saying we're projecting a ball upward, and it's going to go up, and then it's going to come back down. So we'll take a look at what that's going to look like. Okay, so it says give the function that describes the height in terms of time. Well, that's what this is. So this is saying the height in terms of time. So if I put a t in here, I fill in a number, that's going to give me what the height is in feet. All right, so we've already got that given to us. Now it says graph this so that you can have a good picture of it. You want to be able to see the y-intercept, the x-intercept, and the vertex. That's really important that you can see that. So let's come back here. I'm going to stop sharing, and I'm going to share again and bring up. Okay, so let's take a look at this. So we're going to type in that equation that we were given. Let's see, a -16. And I'll just use x instead of t. Doesn't really matter. Plus 80. And then plus 100. So what I'm going to have to do is take a look at this graph. All right, I really can't see like where the top of the graph is. So that means I'm going to have to work on my scale, because I don't know what the graph is. So that's what this is right here. I can click on this tool, and I don't really know for sure what to do on this, so I'm going to kind of mess with it. So my x-axis doesn't look like it's very wide, so I might just do like a -20. All right, I'm just going to type it in off my keyboard. And then here we'll do a +20. And that'll just kind of, hopefully we'll be able to see both sides, both of the legs on that. And then for the y-axis, I don't know, it goes up pretty high. So I could keep pulling this down and seeing, well, where is it? You know, here it is, it's way up here at 200. But I want to be able to see it in one picture. So I know it goes up to about 200. So let's change this to maybe 220. So we have a little bit of room there. This would be a -220. And then we'll do a +220. And let's see if that gives us a better picture. Okay, so how about that? So I can see the y-intercept, the x-intercepts, and the vertex. And that's how you know it's a good graph. Okay, so that's what I'm talking about when you need to be able to see a good graph of this. Now, if you needed to turn something like this on a test, you can copy and you can take a picture of that. You can just snip it and take a picture of it and turn that in as well if you needed to. Okay. Now, the question then, I'm going to come back to this. The question on the notes says, all right, so graph it. So we did that. Okay, so this point, this 4.8 and 115.36 lies on the graph of the function. So what does this mean in particular? So this is your x-axis, and this is your y-axis. So if we're doing time and height, right? So this is going to be your time. So what this is saying is after 4.8 seconds, your ball is going to be projected at 115.36 feet. And this lies on the line. So any point on the line, this tells you the time, and this tells you the height. Okay, and that's what your function showed up here that we talked about right here, right? Initial height in feet. Okay, so this determines the height in terms of time. So here's your time, here's your height. All right, so after how many seconds does a projectile reach its maximum height? And then what is the maximum height? So let's see. So here's our picture. So the question is, how many seconds does it take to reach the maximum height? Well, this is the highest point up here. Right here is your highest point. So how many seconds did it take to get there? Well, it took 2.5 seconds. And then the question is, well, what is the height? What is the maximum height? Well, the highest point on that is 200 feet. So it took 2.5 seconds to project up to 200 feet. That's your maximum height. And it's really simple. When you have a graph, you have a good graph that you can see, a good picture. That's called a comprehensive graph. When you have a good picture, you can see that pretty easily and just trace it on this Desmos. So the question next is, what is the interval of time when the ball is always greater than 160 feet? So what would be the interval of time when it's greater than 160 feet? Well, let's see, we can trace it. Okay, I'm at 156. I get as close as you possibly can. So you can see that's approximately going to be 1 second. If I could just get it exactly there. I may not be able to get it exactly there, and that's okay. But I think you can kind of estimate that that's going to be exactly If I get it to 1, it'd be 160. So hopefully you can see that. I just can't quite get it there. That's about as close. Maybe, let's see, 160. Yeah, it's gonna, well, actually guys, it might be about 0.93. So, you know, this would allow for some flexibility. So what I could do is I could go put 160 in for my Y value and do it by hand, but I'm not gonna ask you guys to do that by hand just because of the time. So I'm just gonna have to kind of, I'm gonna say about 0.93, I think, actually. 0.93, maybe 0.92. Can't quite get it there. So let's just say 0.92. Okay, I'm going to estimate it at 0.92. And then what about over here at 160? Let's get off that point. Over here at 160. So that would be straight across from it. Oops, 160 here would be approximately 4. I'm going to say approximately 4. I feel like this should be 1. So I'm going to estimate it at 1, just so right? That's pretty close. So from 1 to 4 is approximately when that's going to be 160. So when it says, so when is this ball going to be above 160 feet? Well, that's going to be at a approximately as an interval when x is greater, oh, we're writing it as an interval. So I'm going to show you this first. When x is greater than 1 and less than 4. So if I put that in an interval form, it's this. And it didn't say greater than or equal to. That's why we don't put brackets on that. So that's the interval when the ball is higher than 160 feet. And then I think the last question states, when does it hit the ground? When does the ball hit the ground? So if we go back and look at this, when does it hit the ground? Well, it hits the ground. After how many seconds will the ball hit the ground? Well, when this is 0, it's going to be approximately 6 seconds, or 6.04, 6.036. I would be fine with approximately 6 seconds is when it will hit the ground. Okay? So that's something that you can look at with using a calculator. Desmos is really good for this because you can see the points, you can drag points, you know, you can do whatever you need to do to kind of get around. So it gives you a good picture of it. So that's really a good graphing utility to use. So that is all I have. I know it's a lot for quadratics today on 3.2. So thanks for hanging in there.